two transformers operating in parallel. Okay, these two transformers have equal voltage ratios as well as impedances, and he also given that ratio of reactance to resistance are equal in two transformers. Okay, that is x1 by r1, which is equal to x2 by r2. Okay, now we can find phase angle phi is equal to tan inverse of x by r. Now what is phase angle of transformer 1 phi 1, which is equal to phi 2, since x by r ratios are equal. Okay, which implies cos phi 1, that is power factor of transformer 1, is equal to cos phi 2. Okay, what does it mean? That if both power factors are equal and voltage ratios and impedance ratios are equal, load sharing of these two transformers, load sharing is equal. Okay, suppose if total load, that is, you can write in terms of bracket kVA delivered is, let us say, 1 per unit. Okay, now what are the individual kVA ratings? kVA ratings of 1 should be equal to 0.5. kVA rating of transformer 2 should be equal to 0.5. Okay, these two are in per unit. Now since load shared equally, they will divide these kVA ratings equally. Okay, so what is this full load kVA delivered? Full load kVA delivered divided by sum of their individual kVA rating is equal to 1 by 0.5 plus 0.5, which is equal to 1. So option is A, 1 is the answer. When reading 0.1 volt on 10 volt range, okay, we have plus or minus 0.5 reading. Okay, plus or minus 0.5 reading is equal to 0.005. For zero point 0.1 voltage, it is into 0.1, so this is 0.005 volts. Similarly, for plus or minus 1 digit, what does it mean? That 0.01. What is the total value? 0.0105. Okay, this is what reading on 0.1 volt on 10 volt range. Now what is total possible error we have? Total possible error is 0.0105 instead of 0.1. Okay, into 100. So this is 10.5 percentage. Option C. We know form factor for full wave rectifier. Okay, form factor for full wave rectifier is equal to 1.11. Now what is this one? This is Vrms by V average value. Now from this, what is V average? Vrms by 1.11. In question he has given RMS value as 2.22 volts. Since rectifier indicating 2.22 volts, this is 1.11 volts. Okay, which is equal to average voltage is 2. Okay, now we have triangular wave shape as an input. Okay, now if you have triangular wave as an input, peak value is given as 2 times of average value. Okay, 2 times of average value is 4 volts. Now RMS voltage as Vrms is equal to Vm by root 3 for triangular wave. Okay, we know Vm as 4. This is 4 by root 3, which is equal to 2.31 volts. Now what is percentage error here? Percentage error is equal to 2.22. This is measured value. true value is 2.31. Okay, minus 2.31 by 2.31 into 100. This is minus 3.9%. Option A is correct.
Accidents occurring in a city in a day by Poisson variate with mean 0.8. Find the probability that on a randomly selected day there are accidents. So it is given that lambda, which is mean of the Poisson variate, as 0.8, and we have to find the probability that on a selected day there will be accidents. That means there must be at least one accident. So in order to find probability of at least one, it is enough to find 1 minus probability of no accidents. Now, we know the formula for Poisson variate. P of x is equals to k, which is equals to e power minus lambda into lambda power k by k factorial, and lambda is given as 0.8. Now we need P of at least one accident, which is nothing but 1 minus P of no accidents. For this no accidents, value of k will be 0. Just substitute the values. E power minus lambda, that is 0.8, into lambda 0.8 power k 0 by 0 factorial, which is nothing but e power minus 0.8, 1 minus 1 minus, which is equals to 1 minus. If we simplify this value, it will be 0.449, which is equals to 0.551. Hence the required answer is option A.
In this question, we have to find deflecting sensitivity, which is S is equal to L into LD by 2D EA. It is given as L into LD by 2D EA in CRT, which is equal to 3.3 into 10 power minus 2. Length of deflecting plates is 4.5 into 10 power minus 2 by 2 into 10 power minus 2 into EA is 300 volts. Okay, which is equal to 0.2475 mm per volts. Option is D.